Good day, ladies, gents. I haven't made a video in a long time, but this is made by request. This is chapter 5, and we're going to be completing the square. I like putting that in quotes, just because when I say it, I like to do the air quotes, and we're going to complete the square. It sounds weird to me. Anyways, it is May 26th of the year 2020. It's like 33 degrees Celsius right now. It's really, really hot. I got water beside me. I'll probably be going to that every few seconds. Anyways, it's grade 10 math. It's Mr. Benjamin here. Always managed to squeeze that in, which is nice. Happy face. So I'm going to go back to something I posted to my classroom. This is a quick rundown with little text messages involved. These are actually all the steps. I'm going to go through those as well, but this is page 331, number 3 of, who makes our textbook? Nelson Principles of Mathematics 10. So this is the solution to that question. I've already done this with my class. I've gone through it, so I'm not going to bother going through that. What I'm going to do is answer number 3C, which is just 2 questions after that one. And the equation is here. I like this one. Well, I don't like it because it deals with decimals, but I mean, it's an extra step of challenge, whatever. Anyways, steps involved to completing the square, again in quotes. So this is to convert from standard form to vertex form. I didn't write in standard and vertex form, but at this point you should know them. Vertex form is slightly different. I have it written on the bottom here. The beauty about vertex form is that when you're looking at it, this h value is actually your x, and this k value is your y, and that's for your actual vertex. Pretty sure the hand is around here somewhere, so you might not be able to see that, but your h and k are your x and y, and that's literally your vertex when you go to graph. Your a value is a vertical stretch or compression, and yeah, I mean, when you move your h and k, that literally moves where your graph is on the x and y component. Or I should say when you change your h and k. So the first step involved is to factor out a being the first value in your standard form, so your ax squared, that's a. Factor that out from the first 2 terms, so first and second, so that's a and b. Ax squared and bx. Leave c alone. C's a bit of a loner. Leave him alone, he's fine. She's fine. Whoever c might be. It is fine, I should say. C is fine, bottom line, okay? Divide b by 2 and square it. So this is a little equation here, b divided by 2 squared. So if your b value is 4, for example, it would be 4 divided by 2, which is 2, and then 2 squared is 4. It's probably a bad example. Let me do a better number, or a different number, I should say. I didn't want to erase all that. Let's erase this here. If your b value is 12, 12 divided by 2 is 6, 6 squared is 36, okay? What you do with that new value is you add it and subtract it. You do that to c, basically. Now, there's brackets involved because we're grouping terms right here, but basically what it's going to be, there's not going to be any variables involved, so it's just going to be a constant value. So you can add it and subtract it to the equation, which literally does not change the equation, as we know when you add and subtract the same value. And furthermore, the next step is to group the first 3 terms and remove the 4th. Now that's going to be your negative value. So you add the value, you subtract the value, and you take that subtracted value and you take it out of the equation, okay? Finally, you factor. This will always make a perfect square, always. That's why it's called completing the square. That line is really messy. And, you know, your a value is going to be factored out, and then you'll end up with your equation looking like this. Y is equal to a bracket x subtract h bracket squared plus k, and that is literally standard form. Oh, excuse me, that's vertex form. Okay? So, getting into the actual example question. First step. Factor out a. Sorry, I kind of messed up the a there. I'm just going to rewrite that. Brackets, parentheses, quotes. Quotes. Well, I don't know what the actual name for that is. And remember, this is from the first 2 terms. Okay, so I'm factoring out. I'm going to get rid of this line. I should have written this smaller because I'm going to need more room. So what I'm going to end up with is y is equal to 4 bracket x squared subtracts 10 divided by 4 is 2.5. 2.5x plus 1. Okay, now from this point, now divide b by 2. Square it, add plus subtract. Subtract. Sometimes the stylus doesn't pick up. Maybe it's just the way I'm holding it. It's an old style, so I should get a new one. I should really get an Apple pen, but those are expensive. Somebody buy me and send me an Apple pen, okay? Y is equal to 4 bracket x squared subtract 2.5 x. Now this value here. We need to divide by 2 and square it. 2.5, half of 2.5 is 1.25. I know that. But 2.5. I just got my calculator here. Divide by 2. 1.25 squared. I'll write it over here. That's why by 1.25 is 1.5625. I'm going to write out that whole thing. So add and subtract 1.5625. Subtract 1.5625. Okay? And this plus 1 is still there. So we need to have that too. That can be a source of error for many individuals. Now I'm going to refer back to my rules just to make sure we are where we are. So we factored out a, divided b, square it, add and subtract. We've done all that. So now we have to group the first 3 terms. What color should we do this in? Purple. So first term, second term, third term. This we're going to group together, okay? That means this 1.565 has come out of the brackets, which means we need to multiply it by 4. Okay? When I multiply, I'm pretty sure it's 6.25, but I'm going to do it on my calculator. Yeah, we get 6.25. So 4 multiplied by 1.5625 equals 6.25. And of course this is negative, because it's negative 1.5625. So I'm going to rewrite it. 4 x squared subtract 2.5 x plus 1.5625. Now, that's in brackets. What I'm left with is this negative 6.25 as well as plus 1. So I'll write out the whole thing. 6.25 plus 1. But this is going to equal 5.25. We'll write that on our next line. Our last step is to factor, and we get our, we get our vertex form. So let's do that in red. I'll actually write that here. Factor. Y is equal to 4 bracket. Now x squared is x. Negative 2.5. Remember, this is going to be a perfect square. So what are our values going to be? This is just going to be negative 1.25. Is it 1.25? Pretty sure it's 1.25. 1.25. It was 1.565. Yep. Squared plus now this here, well, it's negative actually. Negative 5.25. So this is our vertex form now. Now where these values came from, this 4 has been consistent the whole way, right? This 1.25, if I were to FOIL this out, x subtract 1.25 multiplied by x subtract 1.25. Eventually I'd end up, well, first outside, inside, last. You can do all the work, but you will end up with 1.25, or excuse me, 2.5 there, negative 2.5. And your 1.565, or 1.5625. Okay, so trust me on that. You can do it if you'd like. But I would trust me. Why wouldn't you trust me? And our 525 came from this subtraction right here. Okay, so therefore, vertex occurs at, I got the hand here, so I'm not going to write it there. It's going to be 1.25 and negative 5.25. Alright? Now that just makes it look like a really long 5. I don't want that. One thing to keep in mind, this is negative here, but it's actually positive here. Okay? And I think that's it. Shorter video, 10 minutes, that's good. Wow, gray on white does not look good. Well, I mean it looks fine, it's just hard to see. Maybe if I just go over it a bit. That's a nice effect. Graphic designers everywhere are sad. And I mean that because of me. Anyways, have a fantastic evening.